Look up at the night sky. Go ahead, pick a star, the closest one. Proxima Centauri is over 4 light years away. Our fastest spacecraft today, the Parker Solar Probe, would take over 6,000 years to get there. Voyager, which has been flying for nearly half a century, would need 75,000 years. The universe isn't just big, its scale is a kind of tyranny. It's a cosmic prison sentence, locking humanity in its cradle, a way to design a warp drive that works with the known laws of physics. This is a story about a breakthrough that just happened, a breakthrough that fundamentally changes the conversation. It tells us that the greatest journey in human history is no longer a question of impossible science, but of engineering. And that is a very different challenge indeed, not with exotic, imaginary stuff, but with regular matter. It's a beautiful, inspiring idea. But for decades, it came with a devastating catch buried deep in the math of Einstein's relativity. A catch that turned the whole idea into a scientific dead end. To build a warp drive, the physics told us we needed the impossible. Matter with negative mass, a substance that's never been seen, and probably doesn't even exist. The dream was just that, a dream. For generations, we've dreamed of breaking free. A dream science fiction gave a name to: warp drive. The power to fold space itself, to cross impossible distances in the blink of an eye. But what if that just changed? What if a team of physicists, quietly and without a lot of hype, found a way around the impossible? This isn't a story about a far future fantasy. The impossible dream. Let's be honest, the idea of a warp drive is burned into our brains thanks to Star Trek. The USS Enterprise didn't crawl through space. It elegantly warped space-time, turning the galaxy into its backyard. The concept felt so real, so plausible, it inspired a generation of scientists to ask, could we actually do it? He took the dream from the TV screen and translated it into the language of general relativity. He published a paper showing, mathematically, how a warp drive could work, and it was breathtaking. This bubble would distort the fabric of space-time, compressing space in front of the ship and expanding it behind. In 1994, a Mexican theoretical physicist named Miguel Alcubierre did something amazing. Alcubierre's model showed it was theoretically possible to create a warp bubble around a ship. The surfer isn't paddling like mad through the water. The wave itself, a ripple in the ocean, carries them along. The Alcubierre drive was the same idea, but the ship inside the bubble isn't actually moving through space. It is sitting still in its own little pocket while the bubble gets carried along by the moving space. The crew would feel zero acceleration, no crushing g-forces, because from their point of view, they aren't moving at all. The warp drive was a fun thought experiment, but not a serious way to get to the stars. The price of admission: negative energy was a price the universe just wouldn't pay. The dream was grounded. Any talk about warp drive always ended with the same 3 words. If only. You can't travel through space faster than light, but maybe you could move space itself. Think of a surfer on an ocean wave. It was a stunning piece of theoretical physics. It was elegant, it was brilliant, and it was completely impossible. The Alcubierre drive came with a catch so big, it threw the whole idea back into science fiction. To make it work, the drive needed a ring of what scientists call exotic matter. This isn't just rare stuff. It's matter with properties that, as far as we know, can't exist. If you pushed it, it would move towards you. It messes with our most basic understanding of the world. Some calculations suggested you'd need a chunk of this impossible stuff with the mass energy of Jupiter. Specifically, it needed matter with negative energy density, or negative mass. Everything we've ever seen has positive mass and energy. It pulls things together with gravity. Negative mass would do the opposite. It would be gravitationally repulsive. For nearly 30 years, that was the end of the story. The game-changing breakthrough for 3 decades. That's where things stood. The need for negative energy was like a law of nature. But what if it wasn't a law? What if it was just a limit of our own thinking? In 2024, a team of physicists from a private research group called Applied Physics, working with the University of Alabama in Huntsville, published a paper that sent quiet shockwaves through the propulsion community. The lead author, Jared Fuchs, along with his colleagues Joni Marteri and Christopher Helmerich, presented a new model. They called it the constant velocity subliminal warp drive, and it had one world-changing feature. It doesn't require any negative energy. This is where our story takes a sharp turn. The single biggest barrier that made warp drive a fantasy for 30 years was gone. This wasn't a small tweak. This was a complete paradigm shift, a new solution that works entirely within known physics. Let that sink in. Think of the shift vector as a set of instructions telling spacetime how to flow. The bubble itself still has the compression and expansion of spacetime, but it's generated and sustained by a physical structure we could actually build, in principle. For the first time, a paper on warp drive didn't end with "this is impossible." Instead, it ended with a blueprint. The applied physics team found a different set of instructions that could combine a warp-like field with a shell of regular matter. So, what was the AHR moment? What did Fuchs and his team figure out? The genius of the new design is in how it flips the problem around. Alcubierre's model tried to create the warp effect, using a shell of purely exotic, negative energy. The new model uses a stable shell made of ordinary, positive energy matter. The stuff you, me, and everything we see is made of. The old drive was like trying to levitate a car by inventing a magical anti-gravity road. Great idea, but the road doesn't exist. The new approach is like discovering that if you build a very specific, cleverly shaped sled out of normal steel, the sled can manipulate the existing road in a new way, letting it glide with incredible speed. Its design is just really smart. The key was using a mathematical tool from general relativity called a shift vector in a new way. Here's an analogy. This new model does that. It uses a shell of normal matter, but arranges it in a way that can hold and guide a warp bubble. From impossible to engineer and announcing a warp drive that doesn't need impossible materials is a watershed moment. It reframes the entire quest for the stars. The problem has shifted from impossible physics to monumental engineering, and those two categories are worlds apart. Impossible physics means it can't be done. Monumental engineering means it's incredibly hard, but it's not forbidden by the laws of nature. Warp Factory is an open-source toolkit that lets any physicist in the world simulate and analyze warp drive designs. They can test new ideas, tweak the shell's parameters, and see the effects on spacetime, all on a computer. That's the chasm this 2024 paper crossed. To kickstart this new era of research, the team at Applied Physics developed a software suite called Warp Factory. The paper didn't say, "We're ready to build the Enterprise tomorrow." The engineering challenges are staggering. Let's look at the two biggest. Think about the invention of the wind tunnel for aviation. It changed everything. Suddenly, engineers could test designs safely, cheaply, and quickly. A ship that can travel at, say, 99% the speed of light would be a revolution. A trip to Proxima Centauri would take just over 4 years, not thousands. A journey to the TRAPPIST-1 system, 40 light-years away, becomes a trip a person could make in their lifetime. It makes interstellar colonization something you can actually think about, and passengers inside would still get the main benefit. It's a gentle ride, no matter how fast you're going. This first physical model proves flight is possible. Now the work starts on making it faster and better. Subluminal means it travels slower than light. That might sound like a letdown. What's the point? Warp Factory is the wind tunnel for warp drive research. It opens the field to everyone, inviting collaboration and speeding up discovery. As Gianni Marteri, the CEO of Applied Physics, said, physicists can now generate and refine an array of warp drive designs with just a few clicks, allowing us to advance science at warp speed. Early calculations for a small 10-meter warp bubble suggest the shell would need the mass of a planet like Jupiter. That's a huge hurdle. We can't just grab Jupiter and shape it around a starship. But this is the key. It's an energy and materials problem, not an exotic physics problem. History is a story of humanity figuring out how to control more and more energy. Now, let's be real for a second. First, energy. While the design uses normal matter, it needs a lot of it, compressed to densities we can't imagine. The second major point is the speed. It's called the constant velocity subluminal warp drive. The point is, this is a right flyer moment. It's the first step. The new race to the stars validating that warp effects can be achieved with normal matter has lit a fire under the whole field. For 30 years, warp drive research was a niche, almost fringe topic. Now, it's a serious area of advanced propulsion research. But how do we make it practical? The top priority is tackling those huge energy requirements. Physicists are using tools like Warp Factory to test different bubble shapes. Early work shows that making the bubble flatter might drastically reduce the energy needed, maybe from the mass of a planet down to a large asteroid. That puzzle is now at the heart of the research. We're seeing the birth of a new space race, not between nations, but between scientists and engineers racing against the size of the universe itself. The research focus has completely shifted. The question is no longer is it possible. The race to the stars is on, not with the fantasy machines of old sci-fi, but with the emerging real science of tomorrow. Alongside the theory, the first whispers of real-world experiments are starting. No one is building a full-scale drive, but scientists are talking about creating a microscopic, temporary warp effect in a lab using powerful lasers or magnetic fields. These would be the first baby steps to engineering space-time, moving from a computer screen to reality. This excitement is also attracting talent and funding. Applied Physics even started a warp grant to encourage other researchers to join in. Then the Wright brothers stopped treating it as a physics problem and started treating it as an engineering one. They tinkered, they didn't break any laws of physics, they just found a clever way to use them. That's the moment we're in right now with warp drive. The "it's impossible" phase is over. The "how do we build it" phase has just begun. The topic is moving from pure academia toward applied science. Big-name astrophysicists like Harvard's Avi Loeb have joined Applied Physics to help push the research forward, lending it even more credibility. Think about it like this. In the early 20th century, very smart people proved that heavier-than-air flight was impossible. The road ahead is long. It could take decades, or even centuries, to solve these challenges. But the starting pistol has been fired. The new race to the stars validating that warp effects can be achieved with normal matter has lit a fire under the whole field. For 30 years, warp drive research was a niche, almost fringe topic. Now, it's a serious area of advanced propulsion research. But how do we make it practical? The top priority is tackling those huge energy requirements. Physicists are using tools like Warp Factory to test different bubble shapes. Early work shows that making the bubble flatter might drastically reduce the energy needed, maybe from the mass of a planet down to a large asteroid. That puzzle is now at the heart of the research. We're seeing the birth of a new space race, not between nations, but between scientists and engineers racing against the size of the universe itself. The research focus has completely shifted. The question is no longer is it possible. The race to the stars is on, not with the fantasy machines of old sci-fi, but with the emerging real science of tomorrow. Alongside the theory, the first whispers of real-world experiments are starting. No one is building a full-scale drive, but scientists are talking about creating a microscopic, temporary warp effect in a lab using powerful lasers or magnetic fields. These would be the first baby steps to engineering space-time, moving from a computer screen to reality. This excitement is also attracting talent and funding. Applied Physics even started a warp grant to encourage other researchers to join in. Then the Wright brothers stopped treating it as a physics problem and started treating it as an engineering one. They tinkered, they didn't break any laws of physics, they just found a clever way to use them. That's the moment we're in right now with warp drive. The "it's impossible" phase is over. The "how do we build it" phase has just begun. The topic is moving from pure academia toward applied science. Big-name astrophysicists like Harvard's Avi Loeb have joined Applied Physics to help push the research forward, lending it even more credibility. Think about it like this. In the early 20th century, very smart people proved that heavier-than-air flight was impossible. The road ahead is long. It could take decades, or even centuries, to solve these challenges. But the starting pistol has been fired. This new era of warp research is just getting started, and discoveries are happening faster than ever. The journey from a Jupiter mass energy requirement to a workable starship is one of the most exciting stories in science today. If you want to follow the breakthroughs and understand the challenges that will define our path to the stars, make sure you subscribe and hit the notification bell so you don't miss what comes next. For our entire existence, humanity has been stuck on a tiny speck of dust called Earth, adrift in an ocean of unimaginable size. The dream of crossing that ocean, of visiting other suns, has always felt like a beautiful story we saw in shows like Star Trek, but ultimately, a fantasy. The laws of physics, we were told, had built a wall between us and the stars. The discovery that a warp drive can be designed with normal matter has changed everything. It has pulled the dream out of fiction and into the world of real possibility. The journey to the stars is still long, and the path isn't written yet. But for the very first time, we can say with scientific confidence that the destination is no longer impossible. We're not just dreaming of the stars anymore. We're finally starting to draw the map. But science is never a static set of rules. It's a process, and a recent breakthrough has found a crack in that wall. The challenges are still immense, maybe the greatest engineering task in human history. But they are now engineering challenges, not physical impossibilities.